The square below is divided into 3 rows of equal area. In the top row, the region labeled A has the same area as the region labeled B. In the middle row, the three regions have equal areas, and in the bottom row, the 4 regions have equal areas. What fraction of the square's area is in a region labeled A? Okay, so the fraction of the square's area, I would need to know what this whole thing is. But I'm being specifically asked about how much the A's are taking up. So in the top part, see if you can kind of track this thinking here. I'm going to get rid of this. So you can see A is half of this top row. But if I take this box and I split it up, and let's say it looks something like this. Well, now I can see that A is half the top row, but it is 1/6 of the entire square. So, here's the first part, second, third, fourth, fifth, and sixth. So A takes up 1/6, just that piece right there. If I get rid of that and we think about what's going on in the second row. So in the second row, I'm going to take the square here and we'll split it up and we'll say, now it's going to be broken up into thirds. Well, in that case, this A right here, that takes up 1 out of, and see how many pieces we split this into. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that A right here, just this one, takes up 1/9. And then for the last piece, we're in the bottom row. And so that box splits them into fourths. So I can again kind of imagine that the whole box here is split up into fourths. And so then that helps us see that A is 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is 1/12. So each of these pieces tells me what I've got for each block that said A. So if I want to know the fraction of the square's area labeled A, I just need to add these 3 things together. So when we're adding fractions, we need a common denominator. So we've got 1/6 plus 1/9 plus 1/12. And I could do this by hand. The common denominator is going to end up being 36. So we get, oops, not 4, we get 6 out of 36, 4 out of 36, and 3 out of 36. And if I add these together, that gives me 13 out of 36, and that's answer choice K. But remember, it's a time test. Finding a common denominator could take some time. I could simply just add these together, 1/6 plus 1/9 plus 1/12, and the calculator tells me that that is 0.3611 repeating. And then you have the math frac button on the calculator that would turn this into a fraction for you. And so if you do that, you should get 1336. So the answer is K. The functions y equals sine x and y equals sine of the quantity x plus a plus b for constants a and b are graphed in the standard xy coordinate plane below. The functions have the same maximum value. One of the following statements about the values of a and b is true. Which statement is it? So first of all, there's kind of a lot of just notation things happening here in the question that we're going to have to kind of pull apart here. So first of all, we have y equals sine x, and this is a parent function. We also have y equals sine of x plus a plus b. So what we're looking at here is a transformation. They've just dressed it up as a trig function as opposed to what you're used to seeing. So what you're used to seeing would be looking at, for instance, y equals x squared, a parabola. And then when we talk about how we might transform it, take a look at this. If we have y equals the quantity x minus h squared plus k. So this should look familiar. Remember that h dictates the left and right movement, and k is what tells us if we move up or down. In this one, it's no different. A is where you get your left and right, B is where we get our up and down. So if we look at the two graphs, first of all, sine is this one right here, the one that starts at the origin. Now, knowing that might be helpful, but it wouldn't be a requirement. And certainly if you had a graphing calculator, you could just type in y equals sine x, and you would know that it was that one right there. So when I look at these and I think about A and B, I do see that we do have left and right movement, but we don't have anything that's up and down. So when I look at the choices, here we have A is less than 0 and B equals 0. Now notice all of these B values. So B equaling 0 is only in the first choice. Greater than 0, less than 0, less than 0. So this is what's going to help us get through the problem. B dictates up and down movement. When you look at the graphs here, you'll see that there hasn't been any transformation for up and down. That means that B is, in fact, 0, and the only choice would be A. Which of the following number line graphs shows the solution set to the inequality, the absolute value of the quantity x minus 5 is less than -1? So here would be the shortest way to think about this question. Here we have an absolute value, and they're telling us that it is less than -1. One thing we know about absolute values is that they are always positive. So if they are always positive, when would they ever be less than -1? In other words, more negative. Well, it could never happen. So the answer is K, the empty set. Now, if you had trouble kind of reasoning through that, another thing you could consider would be using the answer choices to help yourself get through this one. So for F, the solution would include real numbers between 4 and 6. And so what's a number that's between 4 and 6? 5. So I can put 5 into the original, and I have the absolute value of 5 minus 5 is less than -1. So 0 is less than -1. That's not true. The answer can't be F. G, same kind of thing here. We've got answers that would be less than 4. So I could pick something that's less than 4, for instance, 3. If I plug that back into the original, I have the absolute value of 3 minus 5, which would be 2. And is 2 less than -1? No. So that answer would be out. H, same thing. This time I could pick something like 7. So 7 minus 5, and then take the absolute value. That would be 2 is less than -1. That's, again, not true. And then for J, we're looking at answers on either side here, but J actually contains G and H separately, those choices rather. So G wasn't true and H wasn't true, therefore J isn't true, and that would mean K has to be the answer. As part of a probability experiment, Elliot is to answer 4 multiple choice questions. For each question, there are 3 possible answers, only one of which is correct. If Elliot randomly and independently answers each question, what is the probability that he will answer the 4 questions correctly? So for probability, we know that we are looking at our favorable outcomes out of the total possible outcomes. So for a single question, there's 3 choices, and the probability of us getting it correct would be 1 out of 3. Since there are 4 questions, we can set it up where we have the probability of getting each of those correct. So the fact that they're independent, that's what tells us that we're allowed to multiply these 3 things together. So 1/3 times 1/3 times 1/3 times 1/3, or 1/3 to the 4th power, however you want to think about it, that ends up being 1/81. The sides of an acute triangle measure 14 centimeters, 18 centimeters, and 20 centimeters, respectively. Which of the following equations, when solved for theta, gives the measure of the smallest angle of the triangle? Then it tells us here, note for any triangle with side lengths lowercase a, lowercase b, and lowercase c, that the opposite angles, which are capital A, B, and C, respectively, then we've got these 2 things that would be true. So you may or may not recognize these things, but if you had trig, you might see that these are the law of sines and the law of cosines. On the ACT, anytime they give you a formula, you're going to use it. So I'm definitely going to be using one of these 2 things. To figure out which one, I'm going to refer back to the original question, and keep in mind that the ACT is meant to test very specific things. So even though this seems like something I can't do, even without knowing trig, like knowing that these two things are the law of sines and law of cosines, I would still be able to work through this problem. First thing I would see is that I've got 14, 18, and 20, and these are all side lengths. So these are A, B, and C, lowercase a, b, and c. And then they also say that we're going to solve for theta. So theta is my unknown. When I look at these two different laws here, in this first law, for the law of sines, notice that the way this works is you only look at two ratios at a time. So I'm either looking at sine A over A equals sine B over B, or sine B over B equals sine C over C, or sine A over A equals sine C over C. So even though there's three equations, we can only look at two at a time. The big thing to take away from this, though, is when I look at just two at a time, notice what the variables represent. There's two angles, which are your capital letters, and there are two lowercase letters, which are your sides. When I look at what I have given to me, I've got three sides and one angle as the unknown. The fact that there is one angle is the giveaway. Law of sines, this guy right here, is not going to be helpful because it has two angles no matter how I choose to pair these things up. So law of sines is not going to help me. If we jump over here to the law of cosines, all I really need to know is how I should appropriately fill this out. Notice that the only angle is C. So for us, theta is going to be C. And they tell me something about theta. Let's look back here. They say when solved for theta, it gives the measure of the smallest angle in the triangle. So when I look at the sides, I know that the smallest angle is opposite the smallest side. So my smallest side is 14. In terms of the formula, if capital C represents the angle of interest, then lowercase c represents the side that's with it. So that would be 14. So 14 is lowercase c. If I start filling this out, we'll have 14 squared equals, and then I've got a and b. So a and b are going to be 18 and 20, and it does not matter where you choose to put them. So we'll do 18 first, so 18 squared plus b, which is 20 squared, minus 2, and then I said a is 18, b is 20, and then we've got cosine of capital C, or cosine of theta in this case. So I actually didn't even need to completely fill this out. As soon as I determined which side needed to be by itself, which is this guy right here, 14, the giveaway would be that the answer is J. So F, G, and H would have been out right away because that's the law of sines. Again, I only knew one angle. The law of sines require that you know two, or know one, and then you're solving for another. And then K would be out because side 20 would be the largest angle, and theta was supposed to be the smallest angle.